Okay, this is the 13th of August, and we are talking about standard form. Now, in standard form, the equation looks different than we had yesterday. The other day we were using vertex form, but all parabolas can be written in standard form, and then you can change them into vertex form. So every parabola has a vertex, so it can be written in vertex form, and every parabola has standard form. So the A number. Now the A number is the only number that's the same on both forms, vertex form and standard form. The A number tells you whether the parabola opens up or down. And so if the parabola opens up, if the parabola opens down, it looks like this, and it has a maximum value. It has the top of the mountain. So if A is a negative number, that's what this means, less than 0. If A is negative, it opens down and it has a maximum. If A is positive, that's what this means. That means it opens up like this. So it has a minimum, like the bottom of the valley. A tells you whether there's a maximum. If it opens down, there has to be a top of the mountain. And if it opens up, then there has to be a lowest point. Now then, in the standard form, the number at the end of the equation is the Y-intercept. So let's just zoom in here a little bit. This number right here, the number at the end, is the Y-intercept. So that means that's the place where it crosses the Y-axis. If I'm over here and I'm drawing my picture, I don't know if I can draw that. No, I can't. So all I have is this is the place where it crosses the Y-axis. And so you know where the Y-axis is. So we're looking for points on the Y-axis here. This value right here is one of those points on the Y-axis. The line of symmetry is the line that cuts a parabola in half. Now remember, every parabola can be is symmetric. So if I have a line right down the middle of this parabola, that's the line of symmetry. So the line of symmetry cuts the parabola right half in two. And then we can find the vertex. Now it's not as easy as it was on vertex form. And we have to be able to write the domain. Now, and the range. The domain is all the possible x values that can go in the parabola. So remember, a parabola can look like this. And remember, it goes forever to the left and forever to the right and forever up. So all possible x values would be all real numbers, because I'm going left forever, down the negative side, right forever, down the positive side. So the domain of parabolas is always the same, all real numbers. But the range changes, and it depends on what the max is or what the minimum is. Like in this graph that I drew here, the minimum is the y, is the center 0, 0. So I would say that the range there would be y greater than or equal to 0. So whenever you write the range, you're going to say how tall it is. Now this goes up forever, right? It's forever tall, but it's not forever down because it stops right there. So if the parabola was upside down, it would go down forever. These arrows would go down forever and ever, but it would have a highest point. So it would have to be all the y values less than whatever this highest point is. So let's do an example of that. So here is an example. So let me clean all this stuff off. So it's going to take a minute to get rid of everything. Now then, what we want to be able to do is find out, does the parabola open up or down? Well, look, this number right here, the A number, tells us that it's positive, so that means the parabola opens up. And the Y-intercept, the number at the end, tells us that it crosses at 5. So if I was going to graph that, 1, 2, 3, 4, 5, see, I already know where it crosses the y-axis. So I did that. Now the equation of the line of symmetry, that's where you had to do the opposite of b divided by 2a. Now if you remember, this number in front is a, this number in the middle is b, and this number at the end is c. So if I'm going to find the equation of the line of symmetry, I'm going to say x equals, and then I'm going to say the opposite of the b number. Now look, the b number is -8. So the opposite of -8 is +8. So I'm going to have +8 divided by 2 times the a number. Well look, the a number is 2. So 2 times 2 would be 4. So 8 divided by 4, that is the line of symmetry. Well, what is that? That's 8 divided by 4 is just 2. So x equals 2 is the line of symmetry. Now remember, that's a vertical line. So here it is. I'm going to draw it as a dotted line right down here. This is the line of symmetry. That means the parabola, this dotted line cuts the parabola in half, exactly down the middle. So I need to find the coordinates of the vertex so I know where to draw it. Now the parabola is going to open up, so it's going to look like this, but I don't know where the bottom is. Is the bottom up here? Is it way down there? Right? Does the parabola look like that? So I need to find the vertex. So I have to plug 2 back up into my original equation. So I have 2 times, I'm going to plug 2 in. Why am I plugging in 2? Because the vertex has to be on this line somewhere. So I'm going to plug in 2. 2 is going to tell me 2 squared is 4. So I'm going to have 2 times 4. Let me write that right here. So I'm looking for y. What the heck is y? Well, it's 2 because of that 2. And then I put 2 in here. That's 2 times 2. That's 4. So 2 times 4. Then it says -8. I'm just copying this. -8 times x. But remember, x is 2. So I'm going to put 2 in there. And then plus 5. So if I do this, 2 times 4 is 8. And then this is 2 times 8 is 16. So this is 8 minus 16 plus 5. Well, you know 8 minus 16 plus 5 is -3. So that means that y equals -3. So if I wanted to know where the vertex is, it's at the x value is 2. And the y value is -3. So look right here, 1, 2, 3. This one right here is the vertex. Now then, I know that it has to go through this dot and it has to go through this dot. So I can draw half of my parabola right now. There it is. But then I know that this is the line of symmetry, so that means that over here there's another one. So if I go, you know, it's symmetric, so if this 5 right here, 0, 5, is 2 away from the center, then that means there's another 5 right there. And so my parabola just comes up, goes through that dot, and then continues going forever and ever. I could draw the picture when I know it opens up, I know where the y-intercept is, and I know what the vertex is. This is the vertex. Now then, the maximum, it doesn't have a maximum. It goes forever. So this is no way, none of there, nothing there. but it does have a minimum value. The minimum value is the lowest y value on the picture. And look, it goes all the way down. The y number here is 5. The y number here is 0. The y number here is -3. But then it goes back up again, 0. So the minimum y value, the minimum value is -3. This is the minimum y value. What's the domain? Remember, that's all real numbers. You can write it like this if you want, from -infinity to +infinity. Remember, what we're saying is that it's infinitely wide. This parabola gets wider and wider. If I pick a number over here, I'm going to have a graph. If I pick a number over here, my graph's going to be way up here, but it's still going to go wide. As it goes tall, it also grows wide. And then what's the range? Well, here, since it's a minimum, it has to be greater than or equal to whatever the lowest value is. And remember, the lowest value is -3. So we're going to say all the y numbers greater than -3. Okay, so let's do one more, and maybe we can do it a little bit faster. Okay, so I need to clean out all of this stuff, and that's the thing that takes a long time. And then I'll find another one. We'll do one that's up with some negative. How's that? Good idea, huh? Negative. Let's do a negative one. So, whoops, I lost my graph. There we go. We'll put it right there. I can't do two things at once. I've got my clicker going, and then there we go. Yay! Okay, does the parabola open up or down? Well, as I can see, I know that it opens down because this is -2. The number in front tells me it opens down. That means the parabola is going to look like this. It's got to open down, just like that. Then it says, find the y-intercept. Well, the y-intercept is the number that's added at the end. Uh-oh, there's no number added at the end. That means the y-intercept is 0. It crosses right there. So that's the y-intercept. Now then, where is the parabola? I know it's upside down. Is it on this side of the graph, or is it on this side? That's our question. Where the heck is the parabola? So I have to find a line of symmetry. Remember, the rule was you take -b and you divide it by 2 times a. That tells you the line of symmetry. So that's going to tell me x equals, and then the line of symmetry is the opposite of the b number. Remember, this is c, this is b, this is a. So the opposite of -12 would be +12. So I have 12 divided by 2 times a. Well, the a number is -2. So 2 times -2 would be -4. Now check this out. That means 12 divided by -4. The line of symmetry is x equals -3. So I know, let me draw it over here for you. 1, 2, 3. There's one. Let's go up here, and 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 down some also. There we go. This is the center line of the parabola. It's the line of symmetry. It cuts it in half. We know that it's upside down, so we know it's going like this. But I don't know where the vertex is. Is it way up here and then come down, or is it right here and then come down? That's our question. So we need to find the vertex. Well, the way I do that, remember, I have to find what y is. So I'm plugging -3 into my equation. Now look, -3 has to be squared, right? So I'm going to take -2, and then I'm going to multiply it times -3 squared. Then I'm going to subtract 12 times -3. Now look, -3 squared, hopefully you remember, negative times negative is positive. This is +9. But +9 times -2 is -18. So I've got negative 18. And then I have negative 12 times negative 3. That's positive 36. So I had 9 times 2, negative 18, and 3 times 12, which is positive 36. And so 18, look, I wrote 33. How silly. What a silly man, huh? There we go. Let's make that say 36. There we go. So I know that 36 minus 18 is 18, and so that means that this is at 18. Now, where is this? How long does this go? 1, that's 2, that's 4, that's 6, that's 8, that's 10, that's 12, that's 14, that's 16, that's 18. So right here is the vertex. That vertex is, remember, negative 3, positive 18. That's the vertex. How do I know? I found it because I found out what y was. Y was this, and when I add that together, I get 18. So that's the vertex. Now that means it has to go down through this one. So I know the left side of my graph is going to look like this. Woohoo! Well then, look, this is 1, 2, 3 away. Over here, 1, 2, 3. Since the graph is symmetric, the other side of my graph has to go down there too. So my parabola looks like this. Now, the domain, does it have a max or min? It's got a max, and that max does not have a min. We're going to cross that out. It has a maximum because it's the highest point. And remember, the maximum is the highest y value. So the maximum value is 18 because that's the highest y value. What's the domain? The domain is all real numbers, right? You can write it in words. You can say all real numbers. Or you can write it like we did on the other one, negative infinity to positive infinity. And then what's the range? Since it's a maximum, it's going to have to be y is less than, because see, that's the highest point. This parabola goes up to 18, and then it comes back down. It never goes up to 20 or 22 or anywhere else. Whoops, 18 was up there. Ha! I do it in the wrong spot. Sorry about that. Wee doggies. There we go. This is wrong. 18 is way up there. That's the max. So it has to be all the numbers less than 18. This parabola was wrong. This is where it was supposed to be. I'm sorry about that. I apologize. And that's it. You should be able to do the homework for the 13th of August.